Alright, welcome to our first video on solubility. But for this aspect, I'll be focusing on the calculation aspect of it. That's the quantitative aspect of this solubility. Without wasting our time, I'm going to quickly give two shortcuts. That's formula by way of shortcut that we can use to get answers to solubility questions easily. In any case, whether it is JAM, whether it is WAEC, whether it is NECO, so far the question is on solubility. These two formulas, sure, they will give you your correct answer. So the first formula we have is that solubility in mole per dm3. This is 1 unit of solubility. The other is also gram per dm3. The first formula is going to be, by way of shortcut, 1000 times m all over v times w. This will give us our solubility in mole per dm3. Now let's explain what the parameters in the formula. The m stands for what? Mass of solute. Now, from basic chemistry, we understood that if a solute is dissolved in a solvent, for example, in your home, you want to make a cup of tea, you dissolve Milo and milk in hot water. The hot water you are dissolving it in is the solvent, while the Milo or the milk you are dissolving in the water is the solute. So that we know that when solute has been added to solvent, the resulting mixture is going to be what? Our solution. Now, the M standing there at the top is the mass of what you are dissolving. That's the mass of the solute. Why the V there stands for the volume in the question. Now, why did I say the volume in the question? Usually, this volume is supposed to be the volume of the solution. But examiners make this mistake of putting volume of solvents to be the volume of solution. So in any case, anytime you are faced with this kind of calculation, take the volume given to you as the volume of the solution, even if the question says the volume of solvent. But usually it's supposed to have been the volume of solution. So that's why I call it the volume in the question. But please bear in mind that this volume in the question, the unit must be in cm3 or in milliliters. If the volume is in cm3 or milliliters, then the 1000 in our formula remains the same. It remains there. But if the volume is in dm³ or liter, if it's in dm³ or liter, then you will remove the 1000 from our formula. So that our formula will become solubility is equals to no 1000 m over v times w. Please take note of this, because when the volume is in dm³ of liter, we no longer need the 1000 in the formula. Now, that's one way of getting the answer easily. Another shortcut, okay, I'll call this one. Another shortcut that will give you your answer fast and reliable is this one. Solubility in mole per dm³ is equals to solute all over solvent times 1000 divided by molar mass. Now this formula says solute divided by solvent multiplied by 1000 divided by molar mass. Now molar mass of what? The molar mass of the solute, just like the W in the first formula. The molar mass of solute. The W here, the W in the first one, is also molar mass or molecular weight of the solute. So W stands for molar mass of what? Of the solute. So that W and this M here represent the same thing. Now this is just the two formula, the two easy ways of getting solubility in this particular unit, mole per dm cube. Now, what about the second unit of solubility? What will be the formula? So formula 3 is for this other unit. Solubility in gram per dm cube. Gram per dm cube is equals to solute all over solvent multiplied by 1000 over 1. This will give you your answer in gram per dm cube. These are ways of getting the answers to the questions easily. So please take note that for solubility in gram per dm cube, it will be solute by solvent multiplied by 1000 divided by 1. And that's 1000. Now, we have some questions we are going to solve here to show example of what these formulas can do. Now, we have the first one as 2010 question 15 Jan. And the question says, calculate the solubility in mole per dm cube of 40 gram of CuSO4, that's copper 2 tetraoxosulfate 6, dissolved in 100 gram of water at 120 degrees Celsius. Now, I can use this formula. So far, the unit of the solubility they say I should find is in mole per dm cube. So look at the unit there. The unit given to us is mole per dm cube. So it means I can use either this formula or I use this one. But to get the answer fast, we make use of this one because this one does not matter the unit of the parameters given to us. But for this one, the volume of the solution is not given to me. So I'm going to solve question 1 right now. So please, if you need to write these formulas down so that I can wipe this board and start solving. All right? So take down this formula 1, 2, 3. Sure bet for the exam. All right. If you have taken down, let's solve this question. Now, solving this question now, if you look at this question very well, it says calculate the solubility in mole per dm cube of 40 gram. What are they dissolving? They are dissolving 40 grams of this substance in 100 grams of water. So now, what is my solute in the question? My solute there is 40 grams. Now, what is my solvent? What I'm dissolving it in? My solvent is what? 100 grams. The temperature there does not matter because we already know that definition of solubility, that solubility of a solute in moles or in grams of a substance can be defined as the number of moles of the solute dissolved in 1 dm cube of water at a particular temperature in the presence of undissolved solute particles. Now, that's why the temperature is there, but it does not have anything to interfere. It cannot interfere anywhere with our solution. So let's continue solving that. Now, the molar mass I can calculate using this substance. This substance is CuSO4. And in the question, I was given copper to be what? 64 plus. The sulfur there is 32 plus 4 times 16. What's the value? Now, if we get that, that will be our molar mass. Alright, so I'll grab my calculator and do that quickly. So we'll have plus 64 plus 32. So we'll have the molar mass today. The molar mass is 160 grams per mole. Now, I will use solubility in mole per dm cube. In mole per dm cube is equals to solute all over solvent times 1000 by what? By molar mass. So I will do that quickly. So solubility becomes, what is the solute? 40 gram by, what is the solvent? That's 100 times 1000. What's the molar mass? That's 160. So that gives me S will be equals to, then this one will be 0.4 multiplied by 160. That will give me 6.25. So that solubility will become, and that's what? 2.5. So the answer to this is 2.50. Clearly option B as our answer. So that formula works faster and reliable. Now, can we use the first one? You know, I use formula 2 for this one. Can we use the first formula? Yes, you can use the first formula. But before you use the first formula, I want to caution you on something. The question did not give us the volume of the solvent. Now, what the question gave us was the mass of the solvent. And what was the solvent? Water. Now, all over the world, we agree that the density of water is 1 gram per cm cube. The density of water is what? 1 gram per cm cube. So that if I want to change this mass to volume, it's very, very possible for me. So I will say that density is equals to mass over volume. So therefore, density of pure water, 1, equals to, what's the mass? The mass is given to me 100. What is the volume? I don't know. Over 1, cross multiply. V times 1 will give us V, equals to 100 times 1, 100 cm cube. So the volume in the question is still 100 cm cube. If we use that for the first formula says solubility in mole per dm cube is equals to what? 1000 times mass of solute over volume times molecular weight. So if we do that in mole per, this particular formula to get our solubility. Now, our solubility is going to be equals to the 1000 times, what's the mass of solute? Look at it there, 40 by, what is the volume now? We have calculated 100 times, what is the weight of this solute? That's 160. Put it there. 0 will cancel 0 there. That one cancel that one. That one cancel that one. 10 times 4 is 40. By 16, that will give us 2.50. So we have obtained the same answer using the two formulas for this calculation. Now, please, if you want to check the answers of obtained and how we solve it, you can pause the video, then write some certain things out. Otherwise, I want to wipe this part to solve the second question. All right, this next question is from 1994, question 19. Question 19. The question says the solubility in mole per dm cube of, this should be 20.2 gram of potassium triosonitrate 5 dissolved in 100 gram of water at room temperature is what? Now, once again, we have been given mass of the solid. So our M will be equals to what? 20.2 gram. Then the mass of the solvent is given to us. So which I will say mass of solvent. This is also solute. So the solvent there is water, and it is what? 100 gram. And then the question now says, okay, what's the solubility in mole per dm cube? So our formula, first one we're going to use, the unit they require it is in mole per dm cube. You must be careful of this unit, because if the unit is not mole per dm cube, then it will be in gram per dm cube. Now, if it is in gram per dm cube, you know what we are going to use is solute over solvent times 1000 over 1. But this time we're going to use solubility in mole per dm cube will be equals to solute all over solvent times 1000 by molar mass. Again, once again, solubility in mole per dm cube will be equals to, what's our solute? See it there. 20. Okay, it's potassium, so that's potassium. So it is KNO3. So potassium plus 95, written like that. Adding it is like 2 plus 95. We are written it like the former one. So this is equal to what's potassium? 39 plus what's nitrogen? 14 plus, what do we have as oxygen? Then there's 3 there. 3 times 16. So when we grab our calculator and do that, what do we get? Class, what do we get? 101. So we get 101 gram per mole as our molar mass. And remember from the calculation, that is our W, or I said that is our molar mass. So put it there and solve. So what will it be here? All over 101. So if we do that, we'll get so this part will give us 0.202 times we get 9.900. So when we multiply our answer by 0.202, what do we obtain? We get our answer as 2.00 mole per dm cube. And where is the 2.00 there? That's option D. Option D is 2.00. And that's our answer. That's by using the first method. So what did we do? We use this formula, solute over solvent times 1000 of molar mass, to obtain our answer fast. What's our solute? See it here. What's our solvent? See it here from the question. Multiply by 1000 in our formula, then molar mass, which we calculated as 101. And our answer is 2. Let's use the first formula, the number 1. The number 1 formula says solubility in mole per dm cube is equals to 1000 times M over V times W. Once again, what they dissolved it in water. And what's the density of water? Density of water is 1. So if density is mass over volume, what's the density of water? 1. What's the mass? The mass is 100 divided by V over 1 plus multiply. We'll have V to be equal to 100 cm cube. Now, to use this formula, we'll say that solubility in mole per dm cube will be equal to 1000 times, what's the mass of the solid there? 20.2 divided by, what's the volume? The volume is 100 times, what's the weight? 101. If you do that in your calculator, you will get 2.00 as your answer. So anywhere we follow, we'll still get the same answer, 2.00. Please, you can pause the video and write the notes down while we move on to solve the last question. All right? Now, the last question. The last question says 117.0 gram of sodium chloride. This is from 2008 question 16. All these are jam pass questions. Subsequent time we solve the one of WAEC, NECO, GCP, like that. Now, 117.0 gram of sodium chloride. So I'll write here. Sodium chloride is written as NaCl. So they said 117.0 gram of sodium chloride was dissolved in 1.0 dm cube of distilled water. Now I have seen that my volume is given to me, and that volume is in dm cube. So volume is 1.0 dm cube, right? Of distilled water. Determine the solubility in mole per dm cube of sodium chloride at that temperature. As simple as that. We can use any of our formula we want. Using the first one, solubility in mole per dm cube will be equals to what? 1000 times m all over what? V times W. But because this volume is in dm cube, then I will remove the 1000 from my formula. So that my formula becomes solubility will be equals to mass over volume times weight. Volume times weight. So that I will have solubility will be equals to, what is the mass in the question? The mass is 117.0 gram. That's 117. So I have 117 divided by what's the volume? That's 1 times. What is the weight? The weight of sodium chloride. Weight of sodium chloride will be obtained as sodium is what? Given to us in the question 23 plus 35.5. And when we do that, what do we get? 23 plus 35.5. We get 58.5. So put 58.5 here, 58.5. We obtain our answer. So 117. The answer will be what? 2.00 mole per dm cube. So here is 2.00 mole per dm cube. Option B is our answer. So thanks for watching this video. This is just for solubility, and these two shortcuts helps you to get your answer as fast as possible and reliable answer. So now, up next, we are going to be looking at other videos coming up soon, such as calculations on electrolysis. Our plan is to make sure that all calculations in chemistry are well covered. So that this is the first one. The second one will cover everything in electrolysis. Do well to subscribe and do well to send us your comments and keep the comment respectful. Thank you.